Okay, completing the last section that we need to for this chapter is 6.3 separation of variables. So basically just going to continue on with what we've been doing the last couple of class periods, but instead of just doing general solutions, now we are going to talk about the particular solutions. So the beginning of this is basically the same. We start with the differential equation. First thing, always the first step, to ensure that we even have a chance at getting the rest of the points on the question is to separate the variables. So I want to go ahead and separate these guys. After doing so, now we can go ahead and integrate each one of these sides to try to come up with our y equals equation. Now ideally we want y equals, remember College Board's always going to ask us for y equals for ease of grading, but I believe there's this an equation that I'm going to do later where we're not going to do that simply because of the nature of the equation itself. So from here, go ahead and get your general solution, and then keep in mind that you can go ahead and pause, do the work, and then I'll catch up with you immediately. So I went ahead and worked it out and I got down to my general solution. Notice that I went through, I adjusted my C1 to capital C once I knew all of the changes were done that were going to be occurring to that constant. At this point, this would be our general solution. However, now that we're going to start talking about the particular solution, we need to make sure that this whole plus or minus is the correct one that we're supposed to be using. So with that said, I'm going to go back up over here to the actual value that was given to me. So I've got that y1 is equal to -4. Well, if y1 is equal to -4, I go back over here, that means that I want my y value to be a negative. So if y1 is equal to -4, then I want the y to be less than 0, which means if I go back up to my general, I don't want the plus or minus part, I just want the minus part of the equation. So you're going to always want to do this as you get to the end where you're going to be plugging in the actual value. Now from here, we're going to use that actual value, the y of 1 is equal to -4, plug those values in for x and y accordingly so we can find the constant. You know from past things that we've done, the only difference between a particular solution and a general solution is the c. We can actually find out what it is. So I'm going to go ahead and plug those in. We're going to solve for c. Once we've solved for c, it's important that wherever it is that you actually plugged the value for x and y in to be able to find the c value, that's the step that you go back to in the equation. So with that, I'm going to take this c and I'm going to plug it back in to that equation right where I started plugging in the x and the y. And then once it's plugged in, I'm done. So here I now have my answer. Notice that it is my particular solution. I don't have a c or a constant or some unknown value still inside, strictly just the variables. Okay, so here we are at the second example in the notes. The process is going to be exactly the same. So first thing, separate your variables. Second thing, get your general solution. So you might want to pause at this moment. I'm going to do the same and work it out. So here I am at my general solution. You will notice that I do not have any subscripts on my C because I'm not really making any changes to it other than the ones that are already shown. So I can't cube root it separate from the other ones. That breaks order of operations. Also, I don't have a plus or minus in front of the cube root, and it's just because of the nature of cube roots are actually roots with, well, odd powered roots. So third, fifth, seventh, there is no plus or minus in front of them. Even, yes, there is plus or minus, and that's when you need to make sure that you double check the sign. So at this point, I'm just going to go ahead and plug in my x and my y using the point that was given to me back up here in the very beginning of the question. So wherever I see an x, I'm going to plug in 2. Wherever I see a y, I'm going to plug in a number 1, whoa, -1, and then I'm going to go ahead and solve for c. Once I solve my c and I end up getting -9, I'm going to do the exact same thing that I did earlier. I'm going to go back to the stage of the equation where I actually started plugging values in to be able to find c, and that's where I resubstitute this back in. So now I have the particular solution that matches with the point that's given to me in the differential equation that was given in the first place. Okay, moving on to the next example, it's the exact same process. So we'll do the same thing. We're just kind of practicing the same thing that we've done the last couple of days, just plugging in some values at the end. So why don't you give this one a shot? See if you can do it all the way through. Make sure that you pay attention if there's any signs that you need to adjust for. This one might be a tiny bit more complicated simply because of the integral that you get, or the result of the integral that you get. But think about what we've done the last couple of class periods. Okay, so I went through and I separated my variables, took the derivative of took the integral of each of the sides. Notice that I did put a subscript on my c because I knew I was going to be using e, therefore adjusting that constant as I went. Then I got down and I simplified it as much as I could down to the stage where I've got y is equal to big C absolute value of x plus 3. Notice that off to the side I explained why I'm dropping the bars, because it's a positive value, but it doesn't drop the bars on the exponent, on the x plus 3. It's simply the y portion of it. Then I went ahead and plugged in my value and I ended up with c is equal to 4, and then I've got my final solution down here at the very bottom. So there is the solution to the differential equation given that specific point. Okay, so here we go with our last example for 6.3 before we do an application problem. So the application will be the last one that we do, but this is just basic. Here's a differential equation. It goes to this point. Find the particular solution. After you finish with this video, so the next slide as well, what I'd like you guys to do is take out the AP question that I gave you last class from the 2018 question number 6, and go ahead and proceed and see if you can do part C. After you've done part C, go to our Schoology page, find the link to the 2017 plus AP College Board questions. I want you to pull up the solutions key and I want you to check your work and see how you did. After that, you're going to move on and work on the book assignment for this assignment, or you'll be getting your test back today, so you'll have an opportunity to go back and take a look at that as well. So, process here is the same. This one looks really a lot like a question that we did in class last time, where you'll notice that we've got some addition and subtraction, kind of stringing x's and y's together. The point of this is you want to be able to create multiplication or division between the variables so that you can easily slide things from one side to the other without having to break any of the rules with the whole dy and the dx. So, separate the variables. Go ahead and proceed and see if we can get the final answer to this one as well. So here we have the last worked out kind of straightforward answer. So I went through, process is basically same from the previous question. Just so you know, next class period we are going to continue doing some more of these. We're going to look at more AP questions though. So you can kind of see the way that they link these questions together and what other things they would have in that part. But then we've got our final answer here for the last one before our application question. So there's my final answer. Okay, moving on to the last slide, and then this is going to be the last one that we do actually for this unit. So, oh, I think I stand corrected. Yes, I do. I apologize. There are 2 more. So, I'm going to go ahead and work this problem out. Process is exactly the same, no different. Let's go ahead and work it out, see what we get, and then we'll move on to the last application question. Okay, so at this point, this one's a little bit different. If you take a look at the left-hand side at the stage that I'm at, you will see that I've got a y cubed and a y. Even if I try factoring, I'm not going to be able to get the y by itself completely. So I'm not even going to try at this point. So maybe if this showed up on the AP exam, I would think multiple choice, but I'm really not thinking free response on this. So, and I think that the multiple choice answer would probably, actually would definitely have the y cubed and the y on the same side. The only thing I can think of that would make this thing look just a little bit better is getting rid of the whole fraction 1/3 in the front. So with that said, I'm just going to multiply everybody by 3 to make it just look a little bit better. And that is an expectation that I would have for the AP exam. Now, if I multiply by 3, this is actually just going to turn into my big C. So I'm not going to do anything else with it because of that y cubed and y. Now, from here, I'm going to go ahead and proceed like I normally would. I just can't get y equals. It's just the nature of the problem. And there we have the last straightforward question solved. Notice that, again, I kept the y's together. It doesn't matter what algebraic method we're going to do. Even if I factored out a y, I'd still be stuck with a y squared minus 3. And then I'd have y's mixed on both sides, and that's no good. So can't really get y by itself at this point. All right, moving on to the last slide. Now we have our application problem. So go ahead and read the question to yourself that's on the screen. And then I'm going to identify some different variables that we're going to use just so we have letters to use as opposed to a whole bunch of different words. Okay, so I'm just going to go ahead and identify some things here. I think I'm going to let A represent air pressure. So I'll go ahead and identify that so I know what I'm talking about as I start writing my equation. And then I'm going to let B equal height. And I'm going to go ahead and identify my units here. So air pressure is in inches, height is in feet. Okay, so I'm going to go ahead and just dissect this thing. So I see that it says air pressure decreases. Okay, that sounds like a rate to me. All right, so air pressure decreases continuously with the height above sea level at a rate proportional. All right, so at a rate proportional to the pressure at that height. All right, so here's what I'm thinking we've got. So I think we've got the rate of the air pressure with regards to height. So I think that that is going to be dA dH, which is then going to be equal to K times A. I don't think I want B to represent height. Let's just do H instead. So I'm going to go back and change that. I'm going to put that as H. All right, I'm just going to go ahead and solve this thing then, or we can recognize what this is actually going to be. But if you don't remember, go ahead and separate the variables, but this should look a lot like the thing that we came up with last class. So go ahead and separate the variables. Remember, K is just a number, and we're going to go ahead and solve. Okay, hopefully this equation looks familiar. It looks a lot like the second equation that we did last class. We just changed some variables based off of the context of the question. Okay, so from here, I know it says that the barometric or the barometer reads 30 inches at sea level. All right, at sea level, the height is 0. So what I know is at H equals 0, I know that A is going to be equal to 30. All right, so if I plug this in to my equation, I should be able to find C, which makes sense because it should be your starting point or your initial value. All right, now we can go back to the equation itself and plug some more information in. So, and then at 15 inches, so and it's at 15 inches at 18,000 feet. So let's go ahead and use that information as well. So I went ahead and plugged in the rest of those values, but notice I already know C. So I'm going to go ahead and plug that in as well. And then from here, all I have to do is solve. So I'm going to go ahead and divide. L on both sides. And then divide by 18,000. That gives me my K. So now I have my constant of proportionality. If I have my constant of proportionality and I have my C, I can go ahead and plug them in and actually get my general equation here. So I've got A is equal to my C, which was 30, and then I've got e to the, well, that interesting looking K value, so I'll put that thing up there. Times my height. All right, so now I've got my equation. So regardless of the height, I should be able to figure out what the pressure is. And I know that the height is 35,000 feet. So I'm going to go ahead and just plug in the 35,000 feet. And I'm just going to type it in. So if I type this in, now this works out to be approximately 7.7944 inches of pressure at a height of 35,000 feet. All right, now that concludes 6.3. Sorry to get your hopes up earlier about that, thinking we were done. So at this point, you are welcome to go back and review this at any point in time. I'll definitely leave it up on Schoology for us. But use this opportunity now to go take a look at the 2018 AP question I gave you last class, see if you can do Part C, and then take a look at the scoring guide and see how you did. Again, we will continue doing a couple more of these next class period, and then the class after that is going to be our test.